going to take a look at solving absolute value inequalities. An inequality is the relation between two expressions that are not equal. So we have four main inequality symbols that we use. The first one is greater than, the second one is greater than or equal to, the third one is less than, and the fourth one is less than or equal to. There are four main steps to solving absolute value inequalities. The first step will be similar to when we solved absolute value equations. You want to isolate the absolute value expression first. Next, you want to set what is inside the absolute value symbol up in two inequalities. So the first one will look the same as what you are given, just without the absolute value bars. And the second one, you will change the inequality sign and change the sign of what is behind it. So again, this is similar to when we solved absolute value equations, and when we look at some examples, it'll make a little more sense. Third, you just want to solve both of those inequalities you set up. And number 4, graph your solutions on a number line, because your graph represents the numbers that would be your solution, because there are going to be more than one number that would make sense with these problems. So I put a little picture right here. We have something like we have OR graphs and we have AND graphs. So if you're given a problem and you are given a greater than or equal to sign, your graph should always look like what we call an OR graph, which means you're going to have numbers that go away from each other, like two sets of numbers that are not overlapping. So something like that is just a random example. An AND graph is when your original problem has a less than or equal to sign. It's an AND graph. So if you spell it wrong, you could think of less than. It's always an AND graph. And great or, again, misspell it, and you can remember it. So less than always looks like an AND graph, which would mean your solution set is between two values. So it looks kind of like that. Again, those are just vague examples, but you'll see later when we do some problems what I'm talking about. A compound inequality is a sentence with two inequality statements joined either by the word or by the word and indicates that both statements of the compound sentence are true at the same time. It is the overlap or intersection of the solution sets for the individual statements. So, for example, if you have x is greater than 2 and x is greater than 4, you would just simply graph x is greater than 4, because that would include the numbers that fall into both of those categories. There's no need to graph numbers that are greater than 2 but not greater than 4. Like 3 would not meet this criteria, that x is greater than 4. So we'll take a look at those, like I say, with some other examples. Alright, so we have 4 examples we're going to take a look at. The absolute value of x minus 2 is less than or equal to 4. So we need to set up our two inequalities. The first one should look like what you're given, just without the absolute value symbols. On the second inequality, you need to switch the inequality sign, so it was less than or equal to, now it's greater than or equal to, and then make that a negative 4. Now we just solve both inequalities, so let's add 2 to both sides. So we get x is less than or equal to 6. And then let's add 2 over here, so we get x is greater than or equal to negative 2. Now look at your original sign of your problem. You had a less than or equal to. So your graph is going to look like the ones we discussed a minute ago. It's going to be an AND looking graph. So it's going to look like this one over here. Alright, so let's take a look at our solution. Again, keeping in mind it's going to look like that type of graph. So I have x is less than or equal to 6. So I'm just going to put 6, 0, and negative 2 to make my life a little easy. And you can do the same for your examples on your paper. So x is less than or equal to 6, so that's a filled-in circle because it's equal to 6. And it's greater than or equal to negative 2. Again, that's filled in because of the equal to bars on each of those. And then solutions that are in between. It's less than or equal to 6 and greater than or equal to negative 2. So all the numbers in between would be solutions to your inequality. All right, let's look at the second example. We have 2 times the absolute value of 3x minus 4 is greater than 22. So first we need to isolate the absolute value by dividing by 2. So then we get the absolute value of 3x minus 4 is greater than 11. So the next step is to set up our 2 inequalities. So 3x minus 4 is greater than 11. Remember, it looks like what you're given. You've just taken away the absolute value symbols. And then we have 3x minus 4, and change your inequality sign and change the sign of the 11, what's on the right side. So now we have our 2 inequalities set up. We're going to start solving each one. So let's add 4 to both sides. So we get 3x is greater than 15. Divide by 3, so we get x is greater than 5. We'll have similar steps on our second inequality. So 3x is less than, we've added 4 to both sides, so less than negative 7. And then let's divide by 3. So x is less than negative 7 thirds. So if we divide 3 into 7, let's make this a mixed number because it'll be easier to graph. 3 goes into 7 2 times. 2 times 3 is 6. So we end up with negative 2 1/3 would be our mixed number. And again, that'll just be a little easier to graph. And then look at your original symbol. So it was greater than. So think it's a great or graph. So looking up here at what we talked about, it's going to look like this one with 2 little pieces that are facing away from each other. So you know what to prepare for. So then, let me draw a number line. And like I had mentioned on the first example, put the numbers you need on there in the right order, and that's enough to represent your solution. So I'm going to put 0 in the middle. I'm just going to put negative 2 1/3 down here on the negative end, and 5 up here on the positive end. X is greater than 5, so I need to leave an open circle because it's not equal to 5. And then shade the numbers greater than, so they would go to the right. And then less than negative 2 1/3. Again, it's not equal to, so leave an open circle and shade to the left to represent the numbers that would be less than negative 2 1/3. Alright, so that's it for that example. Let's look at number 3. We have the absolute value of 1 minus 2x. Minus 2 is greater than or equal to 4. So first we need to isolate our absolute value symbol. So I'm going to add 2 to both sides. So then I have the absolute value of 1 minus 2x is greater than or equal to 6. And now I can set up my 2 inequalities. So the first one looks just like what you're given, minus the absolute value symbols. And the second one, you need to change the sign and change that sign of what's on the right. So it's less than or equal to and negative 6. And then let's start solving. So I'm going to subtract 1 from both sides. I get negative 2x is greater than or equal to 5. Divide by negative 2. And I get, now that I've divided by a negative, my sign changes direction. I get negative 5 halves. So let's make that into a decimal this time. 5 divided by 2 is 2.5. We have an announcement. I'm going to keep solving. So we subtract 1 from both sides on the second inequality, and we have negative 2x is still less than or equal to, because we're just subtracting, negative 7, and then we're dividing by negative 2, so be careful. We've got to change the sign of our inequality. And now negative 7 divided by negative 2 becomes positive 7 halves. And that would be 3.5 to help us graph it. So looking at our original symbol, it was a greater than sign. So our graph should look like an or graph. So let me grab my pen to make my number line. I'm going to put numbers that make good sense on my number line. So I've got 0 in the middle, negative 2.5 on the left, and 3.5 on the right. And then it's less than or equal to negative 2.5. So it's got to be filled in because it's equal to, and shaded to the left to represent numbers that would be less than. And then it's greater than or equal to because it's an than because it's equal to. Okay, so in the last example, let's see, we got a lot of stuff around our absolute value symbols we need to move. So let's subtract 14 first. And leave that -2 for a minute. So -2 times the absolute value of 2x plus 3 is greater than -30. And then we're going to divide both sides by -2. So bring down 2x plus 3, the absolute value of that. But notice I divided by a negative. So if I divide by a negative with inequalities, that changes the sign. So change sign. So we're going to have a less than 15 over here. Now once we get the absolute value symbol by itself, we can set up our two inequalities, just like we've done on the last 3 examples. So let's set up the first one to look like what we have been given right there. And then the next one will be 2x plus 3, change your sign, so it's greater than, and then -15. And solve from there. So let's subtract 3 from both sides. And we bring down 2x is less than 12. Divide both sides by 2, so x is less than 6. And then let's look at the other one. So let's subtract 3. We have 2x is greater than -18. Divide both sides by 2, and x is greater than -9. Now look at your original symbol, just like we've been talking about all along. It's greater than. So it should be greater than, but let's see, we have x is less than 6, greater than -9. So what happened was we had to divide by this -2. So our symbol turned into a less than problem because of that. So you just got to be a little careful, but overall it usually goes with your original sign unless you had to change it before you set up these two equations. Alright, so let's now put it on a number line, thinking of it as our and graph because that sign changed. So I'm going to put 0 in the middle, 6 on the right, and -9 on the left. It's greater than -9 and less than 6, so it's got to go in between the two. Alright, so that's it for 4 good examples on solving absolute value inequalities.